at getting around the intention of the rules.
Now you can get those goggles, the red and blue light ones, and
Ooh.
double up the color.
You know what? Oh my.
Yeah, we need to edit that one. Where's the mute?
Well, the best part was when we got it from Alexander. We just went there and we were like, is this technically cheating? So we just even emailed Dr. Anya just to double check. And she was like, yeah, no, that's fine. We were like, oh, yes.
Y'all are bad.
We're trying to get the data structures to get that. You know how rough those classes are. Data structures there's a reason it's the weed out after the weed out.
All right, so remind me to edit this video since it's got a lot of us just jabbering at the beginning. Okay. Yeah. Just pretend I'm one of the Charlie's Brown teachers and in front of this one. Yeah. All right. So we're going to talk about decisions, also known as conditional statements and if statements. So what this code is going to help us do is if you have a situation where you need to make a choice, I'm going to do something if my condition is true. Or if you need to sort things sometimes. So like 90 and above is an A, 80 to 89 is a B, that sort of thing. So you can check if grade is greater than 90, give them an A, right? So we're gonna work on that. Good morning. Good morning. All right, so types of control structures, we've already done our function calls. We've already done loops. Now we're gonna do conditionals. We're gonna make decisions or select things. It's great. It saves you so much time. So much time saved here. Also, it makes it much easier on the computer. So if it's something you just need to make a choice once instead of putting it into a loop, you can put it into an if statement, and then the extra code that doesn't get used doesn't run. It doesn't have to keep making those tests. Once it finds something that works, it's done. So it cleans it up some. When you get into Java, you'll learn about case switches, which are even better, but we're not going to touch them in here. Okay. All right, so you're going to see them in the form of if, else, if, else. So you can have three different things. You can have an if statement all by itself. That means that there is no secondary condition. It doesn't, you're testing for one thing. If it's true, something's happening. You have an if else, where you're testing for something, and if it's true, you want option A to happen, else you want option B to happen. So if you have two options, you use an if else. If you have multiple tests, like you're trying to sort out whether you have an A, B, C, D, or an F as a grade, then you can have if, else if, else if, else if, else. If you have as many else ifs as you could possibly string together between there. I've never seen anybody run out of the ability to put another else if in there. To the point where it becomes ridiculous to read, but the computer's fine with it. So we're gonna talk about a few logical examples first. They're old examples. I realize that iPhones are much further along than this example's tray. So you can buy an iPhone 10 if you have more than $1,000 in your pocket or in your bank account. Otherwise, you need to take the free Microsoft phone, right? So that's a choice. If you have money, you get the good phone. Else, you get the free phone, right? Whatever you do as a former Microsoft employee, don't get the Microsoft phone. It's bad. I don't even think they sell them anymore. Anyway, my Microsoft supervisor told me that because he had one. So it looks something like this. If you put it in code, you can put a function in where you're passing in a variable that has the amount of money available to the user. The three quotes makes it, or the two quotes makes it a dot dot. Comment, I'll explain those later. Basically, if you use a special comments, it'll pull them all together at the end of the code into a document file. And then you have documentation about what your code is. But again, we'll talk about that a little later. I don't think it's overly important for this class. Then you have the if statement set up, kind of like our for. You have the keyword if. You have a test to see if whatever you're testing for. This case you're testing for if your money is greater than 1,000. A colon to say that I'm at the end of my if statement. And then you int the lines that belong to the if. Just like before. Right? The else portion of it backs out indents and lines up with if. Right? You see how this works? Indentation groups things together. And then it returns which phone which you're going to get in the form of a string. I like nodding. That means you're probably following me. So, oddly enough, this example is really important because you're going to see it again and you're going to get to write it later. And I think the lab. Yeah, I think it's the lab. If not, it's the assignment. You've got to rewrite this. So be aware that you can always go back to the slide if you need to. So if you're determining the grade, if you wrote it out in words, it would look like this. This is called pseudocode. A lot of programmers use it to organize their thoughts. You can mix in some code and actually have the math symbols instead of writing it all out in words. But this is a good way to organize and make sure that you have all of your else ifs lined up correctly, or that you have used the right test. Because if you did this greater than or equal to 90, it works. But if you did it just greater than 90, then you don't get the first grade that's an A. So it helps you work out logic to look at it. Moving on. Oh, look, I did it in code too on the next slide. So if you were coding this in Python, you definitely want to make sure you use the greater than and the equal sign next to each other. You get greater than or equal to. You leave it off, you're going to get slightly skewed results. And you won't know it unless you put in 90 or 80, because all the rest of them will be right. You'll just lose one number in the range. Right? Now, if I did this in a weird order, like I decided I was going to find out B before I found out A, that won't work either.
Oh, based on each other.
Yes. Why? Because they're all interconnected. So if I had 75 as a grade, and I started with, let's say I just flipped it, and I started with 60 and below is an F, 70 and above is a C. Well, okay, well, I found out it's a C. I can stop. But if I went down to the next one, you could keep messing this up. Or a common error, a very common error, is to put the wrong sign in. You meant greater than, but you typed less than. Now, if I did, 75 is less than, and I had less than 90 or less than 80, then it's going to give everything an A. You see what I'm saying? Unless it's over 90. And then it's going to throw that away because it's useless to do with it. Everybody that got an A is going to end up with an F because else catches everything else was left over. Does that make sense? Logic here is to make sure you put them in the right order. And to make sure you have the right test set up, the right symbols. Yes. It's easier once you've done it a few times and you go, oh, I did that. She said I was going to do that. And I didn't believe her. But I did that. I do it still to this day. I live off the equal sign. I think, oh, greater than or equal to. I should have put the equal sign in there, but I type so fast, or I get going in my head so fast that I leave things out, or I mistype and I hit the less than sign instead of the greater than sign. I'm not checking behind myself. And the IDE doesn't know which one you want, and both are equally correct. So it's not gonna catch that. So another example of choice is, if it's like today and there's cloudy and overcast, I probably should have brought an umbrella. But if it was a sunny day, I probably wouldn't bring an umbrella. I never bring an umbrella. There should be a second choice here for you always forget your umbrella. But it hates it. So again, in code, you would check to see if the rain chance is greater than 60. If it is, you're gonna do one thing. I don't know where the rest of the code went for that slide. Remind me to fix that slide. That's an incomplete slide. So control structures let you sort things and make selections. So the ABCD makes you the computer that makes a decision for you. So if I had 1,000 students and I had their numeric grade and I want to know what their letter grade was, I can feed them all into that method and instantly, or seemingly instantly, in nanoseconds, the computer would sort them all out for me. A lot faster than if I'd done it. And I'm not saying I couldn't do it, but the computer's fast. It also lets you make choices. Like I said, if you have two options available to you, you can make those choices. The syntax is always going to be if whatever the condition is and colon afterwards. Now, if you had a variable that only held true or false as a value, because we talked about Boolean variables at the beginning of the semester, you could put that variable there. You could say if true, whatever, then it would run, because that's what it's testing for, true or false. The condition you put in there is either true or it's false. So greater than, less than equates to true or false to the computer. You can do equals to. If you do equal to, remember to use the double equal signs and not a single equal sign because they're different. Bless you. But anything that will give you a true or false can go in your if statement. You could have a function that returns true or false. You can call that function. So when you're thinking about ifs, always remember the question you're asking needs to have a true or false answer, or in your head, yes or no, because yes or no is basically true or false. If you have some ambiguity to it, and it's going to be more than those two answers, maybe falls in there, probably not a good place to use it. All right, so here's one for the ages for all of you young folks, because old folks don't go this way. If you have studied for 10 hours, haven't studied for 10 hours, then you need to study some more. I don't know a college student out there that studies 10 hours a week or a day or a month even sometimes. But if you haven't studied for at least 10 hours, you need to go study some more. Basically what it's saying. So we check to see if study time is less than 10. If it is, we're going to send you back to the study. That's a really bad example. Just go with it. If you have studied more than 10 hours, you can go to Snapchat. I didn't write the slide. I'm sorry. It's not funny. So when you're doing if and else, you have two conditions. If you use else if, you have more than two conditions. You can have an if without an else, You cannot have an else without an if. And if you didn't notice, Python got really, really lazy and doesn't spell out else if. It was just too hard to type those extra 2 characters. So it's ELIF for else if. Python doesn't use spaces.
Yeah.
Now Java uses else if. Sorry, they weren't as lazy. So remember ELIF is short for else if. So this reads, if condition 1 is true, I'm going to do the alternative one. Else if condition 2 is true, I'm going with alternative 2. Else if condition 3, I'm going with alternative 3. If none of those 3 things are true, I'm going with alternative 4. Does that make sense?
And so we have all of, like, not all of this, but like the further condition. What will we have in our parameters? Just greater than or equal to or the true? and false?
Anything that equates to true or false will go in
Okay.
there. The condition has to be something that the computer can go, huh, that's true. No, that's false. That makes sense? So back to our letter grade one. Once we know what the score is or the numeric grade for a student is, it's going to go through this. So if I have somebody give me a number.
30.
30. Okay. So it's going to come through and it's going to test 30 is greater than or equal to 90. No. So it skips over and comes down here. Right? 30 is greater than or equal to 80. False. Skips the indented stuff and comes to the next one. And it keeps going until it finds one that 30 is true, or it gets to the else. In this case, 30 falls into the else bucket because it's not one of our choices. Now, if I used 85 as a number, I'd go through and grade would turn into 85. 85 is greater than or equal to 90? No. So I skip that one. Else if greater is 85 is greater than or equal to 80. True, it is. So now I'm going to do the indented line, and I never evaluate the stuff below it. So I save all those tests, which makes your computer program faster because it didn't have to run all the tests. That makes sense? What is wrong with this?
The sign.
It's the if statement.
It's like, oh, wait, no, it's not that. It's like the else at the bottom. It doesn't say.
There's no else in it.
Yeah.
Yeah,
It
it should be, if you do this, they're independent if statements, every one of them runs. So if I took that 85 I had, right? The first if statement doesn't run. Because 85 is still less than 90. But if I do 85 is greater than or equal to 80, true. So now I change letter grade to B. Then I get to this if 85 is greater than or equal to 70. Oh, that's true too. So now I'm going to change it to C. And it's greater than or equal to 60. So now I change it to D. So everything less than 90 eventually turns into a D because every one of these if statements ran because they weren't connected to each other. They're independent tests. The else if connects them together and says, hey, once you find one that works, don't do the rest of them. That makes sense? This is also a very common mistake you'll see, especially in Python, because leaving the EL off of else if is really easy because your brain is used to typing if as a word, but not used to typing ELIF. So this All of this code will compile. You will not get a compile error with this. Python is perfectly happy to run all these if statements for you. You will have a logical error though, because it will change things that you didn't mean to change. That makes sense? Again, Boolean expressions equate to true or false. Not a string, but actual values, true and false. In Python, these are going to be some of your special cases. True is a capital T for true, and F is a capital F for false. You know, I told you that we don't use capital letters except in special cases. This is one of them. So, if your age is less than 21, that equates to true or false. Mine hasn't been less than 21 in a very, very long time. If you run the function finish with homework, you either are or you're not. Right? You either have money that's more than $500 where you can pay your bills, or you don't. Right? If you're lucky, you're still living at home with mom and you don't have a lot of bills. So this one has an and in it. So we're going to do some logic with and or, because you can test for more than one thing. If it's greater than 10 and less than 20, you can do something. So you made a range out of it. Or if you did your homework or you didn't have any, you can go out to the party tonight. One of those things has to be true, or and both of them have to be. There is a not function, so you can do not equal to, not greater than, not less than. Kind of like negating the whole thing. Not true, not false. You actually can do that. You put a not sign in front of the words. I don't know why you wouldn't just write the other word, but you can do that. So when you're using and or, that's the important part of this chart. If A is false and B is false, and you have an and between them, the whole thing equates to false, because and means both have to be true. So if you go down the and column, the only time it's true is when A and B are both true. Or is true if either one of them or both of them is true. So it's like in the real world. If your mother or your boss says, gives you a list and it says, do this and that, they expect you to do all of the steps, right? If they say, do this or that, then you have a choice. Not with a parent. No. I'm a parent, I can say that. So here's some common operators that you're going to use. Double equal sign is going to compare to see if they're equal to each other. If you use a single one, it's assigning a value to a variable. And so they grab the door, please. Not equal to has an exclamation point. The exclamation point means not. So anytime you see an exclamation point in front of something, read it as not equal to. Less than or equal to, used to, greater than, you're used to, greater than or equal to. So those are all things. So examples over here, 3 is not equal to 2. That is absolutely true. 3 is not 2. 13 is greater than 2. You see what I'm saying, right? If you do 2 is not equal to 2, you're going to get a false result, because they are equal to each other. All of these statements can evaluate to true down here. Once you assign a variable, the variables can evaluate the true or false based on those assignments. These are just examples for you to look at. I'm not reading them all to you. Feel free to go back to the slides. You can download these slides anytime, of course, and go through them. Oddly enough, you can even copy and paste code from them. You just have to do a little editing. We're not doing those. So the rest of the class, we're going to do lab 5. I am going to go ahead and leave the recording on because, well, why not? There'll be two recordings for lab 5, one with a presentation in front of it, one without it. So if you guys want to pull up lab 5 and idle, we'll go ahead and get that started, and then you guys will be caught up with my other class. And I gotta find this. So lab 5. Should have had that open already. So if we read through lab 5, we're going to do some copying and pasting. I gave you one of the functions already, and you're just going to modify it. And then the second part of it is we're going to make a decision on when you get to go to bed and how late you get to stay up. And then the third part is that A, B, C, D range that we've done in class. I've shown in class a couple times now, right? And if you have the slide deck open, you access the code. Or if you took a picture of it. I saw several people taking pictures of them. Which is fine, I'm good with that. All right, so what?
No, I was just looking. And I was saying we still have to do main.
Oh, yeah,
Always
you,
have to do
you from here on out, you're gonna have a main. Just be aware that from now on, you will always have a main method function, whatever you want to call it. So just make the font big enough for everybody to see it in the back. So go ahead and start off with your main method function, whichever way you want to call it. So let's see. First thing it tells you to do is put a print line with your name and what lab it is. So I'm going to go ahead and put my call to main in, because if I don't, I'll forget. And then I'll put some blank lines in between the two where I can add the new code. Right? Everybody good? All right, so the next part tells us it literally says in the directions, copy and paste. So I'm going to grab this, and that's the reason I gave you a Word doc instead of a PDF. And I'm going to copy it, and I'm going to paste it right here. Right? So this one is going to display a simple message depending on the length of the names. So right now, all it does is tells me the total length of the names, you and me, whatever's passed in is you and me, right? So if I call this in main, just to make sure it works, it's always a good idea to test anything you copy and pasted to make sure it works, especially if you get it from the internet and not from me. Not that you would ever do that. Yeah, you would. So I'm testing, so I'm going to put in real names in here because it's in the main and we're doing testing. And I was going to use Garrett, but then I realized it's at the same length and that didn't really help me. All right. Unless yeah. Now I counted wrong. Is there 2 T's or 1 T? Anyway.
2 R's and 2 T's.
Okay, then it would have worked. All right, so if I run this with 2 names in it, it should tell me that the total length is 10 because Tracy's 6, Alex is 4, right? Right. Oh, guess I have to save it, don't I? So it works. It printed out the 2 names and it printed out the total combined length, right? So my copy and pasting skills are on point today. I got all the lines I needed and I copied them in. So now the next step wants us to modify that code. So once we modify it, it should print out what the value of u was, what the value of me was, the length, and tell me which one is longer. And by how many characters it's longer. So let's break down into steps first. This is why I tell y'all to read everything before you start coding. First thing we need to know is if you or me is the longer. As I said, we need to know if. So we're going to use an if statement. Also, we're teaching ifs, so we're going to use a lot of if statements. So I need to add an if statement in here that will test to see which one's longer. So we already have variables set up in our function to tell me that hold the length of u and hold the length of me. Which is great. Means we don't have to go calculate that again, right? So inside of my if, I'm going to set it up if length u is greater than length of me. Oh, sorry, no parentheses. I'm doing Java again. So if u is greater, the length of u is greater than the length of me, I'm going to do some stuff, right? I need a print statement because I need to print out which one's longer, but I also need to know what the difference between the two of them are. So let's create a variable to hold that difference.
Do we have to write out a full like length?
For the variable name, yes, because that's
Okay.
what the variable is named in this function. If you had written this entire function by yourself without copying and pasting it, then you could have made it something shorter. But because you copy and pasted, you have to use the variables again. So to get the difference, the difference is going to be equal to the length of u minus the length of me. Right? Because we figured out that u is longer, so we're going to subtract me from u. Yes. And now I'm going to put my print statement together. So what do I need to print? Jane has the shorter name by 2 characters. So my print statement is going to tell the name of the shorter one. Right? So in this case, I need it to print out me, comma, bad when you can't spell. So if we do this, it's going to print whatever's underneath. It's going to print the string is shorter than, is the shorter name by, then the whatever's in difference, and the character, right? Else if, and why am I using else if? Because if they're equal to each other, I have to print out a third option. Right?
The word of evidence you print if both lengths are the same. length.
We're gonna do it if both of the names are the same. That's gonna be our third option. That's gonna be an else. So else if me is longer, so now we're gonna do the same thing. And I'm gonna be lazy and copy and paste. You guys do what you need to do. So everywhere I have, this time I want if length of you is less than length of me, right? That makes sense. So now you shorter than me. I'm going to change this to where I'm subtracting from me instead of you. Why am I changing this one? Because if I don't, I get a negative number. And then difference doesn't make sense because it's negative. Everybody follow what I did? Okay. And then the print line's the same, except now I need it to also be change me to you, because you is now the shorter. All right. And then the one last thing we have to take into consideration is if they're equal to each other, we don't have to test for that because we've covered everything else. So I'm just going to use an else statement. I'm going to put the names the same way. You can read the directions and print exactly whatever it says, the directions you want to, but something similar to that should do it. Does that make sense? So now I have three possibilities. And to make sure that I covered all three of them, I'm going to call the function 3 times. Just to make sure that I've tested for all options. So if I put reverse this and make Alex first and Tracy second, and then if I make these the same length, either come up with a 4-letter word or 4-letter name and then a 6th one. So now what I'm doing is I'm going to run it, and the function's going to be called 3 times. The first time it's called you is going to be longer. The second time me is longer, and the third time they're equal to each other. So I should have 3 sets of prints with the last print statement being different in each one. Let's run it and see what happens, out of curiosity's sake. So the first one through, Alex has the shorter name. That's true. The second time through, Alex again is the shorter name, but it swapped what you and me was. I guess I should have used different names where it would be clearer. And then the last time through, the length of the names is 8, and the names are the same length. So it works, right? And I tested for all 3. Why did I test for all 3? Because if you'd only tested it once, there is the possibility that you would have done something wrong in the different sections of the if and not gotten exactly the results you wanted for the other options. And I'm going to tell you, when you're coding late at night and you just want to get it turned in before the due date, it's really tempting not to test for all the options and just assume it works. But take it from my experience, that sometimes bites you. Because it looks good, it worked one time, doesn't mean it'll work every time if you don't do the third testing. All right, so that is all of that part. Part 2 wants you to make a decision and return the value from a function. So the only difference here is we're going to use an if statement to return something, or we're going to use a function to return value. We've been doing this. We've done this before. When we return a value from a function, remember in Maine, when we call it, or wherever we call it, it either has to be inside of a print, or it has to be equal to a variable, or we lose that information. Garrett, can you look at hers, please? So we are going, to make a function called go to bed. And based on how many hours of sleep the user got the night before, we're going to decide whether or not they can stay up past 10 p.m. or if they need to go to bed. If you're over 40 like me, you always need to go to bed. All right, so we're going to write this function. I'm going to put some more blank lines in where it moves you up the screen where y'all can see what I'm writing. So we're going to define a function called go to bed. Go to bed should take the hours you slept. I'm going to skip the doc string thing. You just put a comment in if you want to, or if you want to use the doc strings, use the doc strings. Doesn't matter to me. We're going to say if hour slept is less than or equal to 5.5, then we tell you to go to bed before 10. Otherwise, you can stay up past midnight. So if hours slept is less than or equal to 5.5, I did it again. Then we're gonna return the string. You need to go to bed before 10 p.m. Right? Otherwise, you return the string, you can stay up past midnight. So that was a pretty simple function, right? So the only tricky part of that is putting it in your main. So because it is returning a value, and I'm going to comment these three out just where we don't have a whole bunch of stuff scrolling on our test window. If you comment them out, make sure you uncomment them before you turn them in. So up here, I'm going to set up a variable called message to hold the value. And then I'm going to call go to bed. And for testing purposes, I'm putting in 7.5. My numlock was not on. Silly numlock. And then I'm going to print whatever was in message. Or if you want to save yourself a little bit of typing, you could put print all on one line. Either option works. If you think you need that message again later in your code, put in a variable. If you know you're only going to print it once, feel free to put it all in one line. So if I run this now, I should get two messages. I tested it for both options. One's under 5.5 and one's over 5.5, right? So one person gets to stay up past midnight and one person gets to go to bed before 10. Syntax error. What?
Mhm.
It happens to the best of us. Wrong window still. Hours slept.
Where we define go to bed? No,
Uh-uh.
Let me go back to your statement.
Oh, it's because I hit enter. This
Oh.
has nothing to do with the code. Let's just close this window
Right.
and run it again. It runs fine. It's because I was trying to get it to scroll up and read it. It did not like that.
Never does.
This is why we don't want you to do a lot of, this is why we don't want you to code in the shell window for very long, because it's not. It increases your frustration level. All right. So we've done that part. So now we've done part 1 and 2. Part 3 is that branching if statement about assigning letter grades. Right?
Do you want us to write part 2 inside?
Yeah, always use your comments. Just because I don't do them in class doesn't mean that you shouldn't follow directions and use comments. I like comments. Those of us grading like comments, especially if you put a comment in breaking up the different parts, because then we know what we're looking at. So part 3, we want to do one called determine the letter grade. We are going to pass in the numeric score and tell it what it is. We're also going to write a second function that is going to allow the user to give us those grades. This is why I tell you to read things before you start typing, because it makes it a little bit different. The second function is the one that's going to use the input statements to give the user the input grades. So the first function can't be tested until you write the second function, because you don't have the grades. Yes. Some people would say, okay, well, I'm going to write the second one first. Either way, I don't care. But so we're going to have 2 functions for this part: get student grades and determine letter grade. I'm just going to write them in the order that they're on the sheet for this example. So going to define and determine letter grade. It's going to take a score, and based on that score, it's going to tell us whether it's an A, B, C, or D. There is more than one way to write this. You absolutely can write a variable to keep up with the letter grade, or you can just have it return the letter grade inside the if. So this one says to create a local variable, so you have direct instructions telling you to create grade. And for the time being, we're going to set it into equal to not determined, or something like that. Not assigned is what they have in the, okay, we'll go with that. And then I'm going to have an if statement, a long string of if statements. This is if score is greater than or equal to 90, grade equals A. Else, if score is greater than or equal to 80, grade equals C. Else, if score is greater than or equal to 70, grade equals C. This example is shorter when you're doing it with high school students because Ds don't exist in most high schools. Did you ever get a D in high school?
No,
Hmm.
I also never really failed.
Isn't it being like an F?
In high school it is. In college, no, it means you passed, you just didn't do very well. And you do not want to get a lot of Ds on your transcript because it will kill your GPA, and if you have hope, you won't have it for long. I made 1D in college, and my GPA never saw above a 3.0 again. Okay, to 2.9 by the time I graduated, but. All right, the second function we have to write is get student grades. This one is not going to take any information, it's going to get information. So we don't have to pass any variable, any parameters in. We want to prompt the user for the number of students grades to enter. We're going to convert that value to an integer. Don't forget to convert your values from input statements. We're going to write a for loop that will run for the number of students you have. We're going to ask the user to enter the grade for each student inside that loop. And then we're going to call determine grade, letter grade, and print out what the letter grade is. So these 3 steps here are all inside the for loop. Does that make sense? All right, so down here, I need number of students. So num students is equal to input. Enter the number of students. Num students needs to be converted. Then I'm going to have a for loop for I in range of the number of students. Oops. Now in here, I need to get the grade for each one, right? So I'm going to set up another variable called grade. It's going to be equal to the input. Now this is where it gets tricky. I want to, the example says that I have to use the grade ID for the student. So if it's student 1, student 2, student 3. That makes sense? So if I go up here and look at my sample output, enter student 2's score is what I'm asking them to do. We did this earlier in another lab or assignment, but just in case you forgot, we want you to practice it again. So to do that, I'm going to type enter student. Right? Y'all remember this? So remember in an input statement, we have to convert a number to a string. So we're using I because it's keeping up with what count we are in our loop. Putting the +1 on there because our loop started at 0, so this throws the right number to the string. Y'all remember doing this before when we were doing like
I remember. I never
temps
watched
or
it.
days or something? right? So we're gonna do that. After we do that, grade has been entered, but it has been entered again as a string, so we need to go ahead and change grade to a number. Since we're only taking whole numbers right now, we'll use int. If we were taking decimal points, we would make it a float, but we're just gonna do whole numbers. And then inside of here, we're gonna have an if statement. No, we're not. We're gonna call determine grade. But remember, determine grade is returning something. So we have to make a choice. We either need to put that value into a variable, or we need to incorporate it into our print statement. Well, all this needs to do is print out stuff, right? So I'm just going to incorporate it into a print statement because I'm not using this information again. So I need to print oddly enough, we're going to use some similar things up here. We're going to do student now. Print statements use commas. Input statement uses plus signs. I tell you the truth, you can use the plus signs in the print statement too, and it'll still work. Right? So now it's just going to print out, right? And it's going to print for each student. I called the function here, and whatever it returns will go into the print statement. That make sense? Yeah. Yes. I don't know. It just did earlier this week when I did it. I probably would go ahead and put it in just for giggles, but we're going to run it this way just to do some testing. So up here, I'm going to go and I'm going to call now if I run it, enter the number of students, let's say 3. The first student, I'm going to give them an 89. Second student, we'll give them a 75. And the third student is going to be really smart and get an A. For some reason, print statements and input statements are different. The input statement needs a string. So the reason you use plus signs up there is you're actually concatenating the pieces together into a string to print out to the string. That's the reason you need to convert numbers to a string. This is only a Python thing. Java doesn't care. It would just put the number in either way. So that is all the code for the 2 functions for part 3. Questions? I see a few kind of confused or perplexed looks. Yes. These 2 functions are part 3. If you have an error message, raise your hand and Garrett or I'll come look at it. Oh, you have a comma and a plus sign.
Oh,
That whole print versus input. I wish Python hadn't done it, but it did. Somebody else. So it makes enough to drive in the pipeline yet? Yeah. Herman letter grade does have.
Check them out, they all have that, yeah.
it should be
You're
graded
signing grade
for
twig.
score.
String, but you're checking the score to get that string.
Minute return. But the reason you're.
Oh.
No, up there you are.
Oh.
Because. you do all the other one is- We have a problem.
Or, no, I'm sorry.
You used all this. You know, when I said what's wrong with this slide, you just proved that you do that. I like it when somebody proves, right? There you go. Now you understand why you want to chain them together. Yes, sir. So
Right now, it's
it's
not
not-
easy. By itself.
So let me check.
You know how to find it.
Right, but
So what does that mean? Usually?
because you have to remember that
Hours slept.
you,
Hours slept is
me,
just not fluid out.
so
Really
it's
working
like,
right now, it's not getting anything. We want that.
one of these. This one needs to be.
Check that out.
So this right here. You're right, that was me, this one right here.
And you want to speak.
Really short.
Also, 1 second.
So that one's- They need bigger screens where you can see it better.
No, maybe the public there.
All right, who needs help?
It says my number of students is not fine. I'm gonna ask that I'm not students. Okay.
Yeah, look at check.
Yeah.
And it says, find it.
Because you called it non-students there and non-student. Line above it. You just have to make sure that they're identical. Spell check would be great. Yes. One of you really smart people needs to create an IDE that has spell check. I'm putting that on your generation. What can the old generation do? Because they're old and tired. Here, will you stop the recording and give a chance? Who needs me? Which one?
Look at your code, look at your main.
So on line 55, you have a-
Determine letter grades doesn't have the parentheses to call it function.